Now, in this class we will discuss some of the applications of the equations of motions and mechanical energy, and we shall try to understand some flow measuring devices like Venturimeter, orifice meter, Pitot tube, etc. in this lecture. Now, before starting about the Venturimeter, which is a device used for measuring the flow rate through a pipe, I would like to discuss some concept of boundary layer which are important, right. So, here we have the boundary layer concept. In this boundary layer will always come into existence whenever there is a interaction of moving fluid to the solid boundary or stationary fluid and moving boundary. Because whenever we have a solid surface, in this solid surface, like in this figure we have a ball here and we have a fluid flowing in this direction, right. Fluid cannot enter into this ball, so that is why the fluid velocity perpendicular to the wall surface must be 0. This is the first condition, and second condition is that since because of the viscous effects, the velocity of the particles which are in contact with the solid surface must be equal to 0. So, it means that these molecules of the fluid which are moving in x direction, as they come in the contact with the solid surface, they must attain the velocity which is equal to velocity of the moving object, and if object is not moving, then the velocity of the particle which are in the vicinity or which are at 0 distance from the solid boundary must be equal to 0. This condition is called no slip condition, right. So, with the help of these two videos we can understand the concept of boundary layer. Here we have a ball which is kept in a moving fluid. Now, we can understand that these streamlines, they are getting diverged, and here these streamlines are getting separated and a boundary layer is formed, right. To further understand it, we have another video in which with the help of some technique we have some visualization, and with the help of visualization we can understand that what happens to the fluid flow near the surface when the fluid comes in contact with this solid boundary. So, in this case, very close to the surface, a velocity gradient is formed, and we can visualize that these fluid particles which are made to visible, they are getting attached to this surface, and in the vicinity of the wall we have velocity gradient. So, it means that whenever fluid comes in contact with the solid surface, the velocity at the solid surface will become equal to the velocity of the solid surface. If solid surface is not moving, it means velocity of the fluid particles will become 0, and the velocity perpendicular to particular area of the solid surface must be equal to 0, right, because fluid cannot enter into the solid boundary, right, and as we move away from the solid boundary, the velocity increases, and in the vicinity of the solid boundary we have a velocity gradient. So, outside the boundary layer we may not have the velocity gradient. This velocity will become equal to free stream velocity, and the transverse distance measured from solid boundary to the point where velocity becomes equal to 99% of the free stream velocity, that transverse distance is called boundary layer thickness, and most of the book this boundary layer thickness is designated by delta, right. So, after understanding the boundary layer concept, we will try to understand the separation. What is boundary layer separation? So, for understanding the boundary layer separation, we have a fluid flowing in x direction over a shape which is having a aerofoil shape. In this aerofoil shape, these boundaries are not getting separated. Only at this point this fluid is getting separated, and rest of the point this fluid is in contact with the solid boundary. Now, to understand what is the meaning of separation, let us see this video. In this one we have a flow in x direction, and this aerofoil is kept in different manner. Now, in this video we can visualize that from this portion to this portion this fluid is separated. So, in the downstream side of this aerofoil we have a wake where fluid is said to be separated, but on this surface this fluid is in contact with the solid boundary, and here also fluid is in contact with solid boundary, here also this fluid is in contact with solid boundary. Only in this back side it is getting separated, right. So, what is the meaning of separation? That when at boundary layer near the solid boundary velocity has to be 0. If velocity is not equal to 0, then there will be a reverse flow, or there will be rolling back of fluid particle. When there is rolling back of fluid particles, then this situation is said that fluid is separated. So, now with the help of these videos we have been able to understand or appreciate what is boundary layer, how boundary layer is formed, and what is separation, and what is the attached flow.